In this video, we're going to do some forecasting using Facebook's model called Prophet. This model is designed to be super easy to use and very intuitive, based on an additive model, which basically means that it breaks down the forecast into different components. And you'll see how this forecast breaks down into yearly, weekly, and even hourly trends. In a previous video, I did show how you can use XGBoost to do forecasting, but there are some limitations of doing forecasting that way. Mainly, you can't forecast anything that's outside of the historic values. But you'll see with Prophet that is possible because it uses this additive type of model. Everything I'm doing is in a Kaggle notebook, which I'll link down below. You can copy and explore the data on your own. And don't forget to like and subscribe. That helps me out a lot. All right, let's go. Okay, so here we are in the notebook where I'm going to be doing time series forecasting using Prophet. But before we get too far, I do want to talk about some types of time series data that you might be working with. So of course, we're assuming that our data has some sort of trend inherently in it that our model is going to pick up on. And those types of trends can be very different depending on your time series data. We can have seasonal patterns, we can have increasing trends, either linear or quadratic or any other type of function. And then we can also have a combination of either of these. And you're going to see exactly how the Prophet model breaks these things down when we train it on our data set. Speaking of which, the data that I have loaded here in this notebook is hourly energy consumption, which I've used in my previous tutorials, and it has over 10 years of historic data that we can train and evaluate our model on. Okay, first thing we need to do is do some imports. We've imported NumPy, Pandas, Seaborn for visualization, and Matplotlib. And then here's the import that we care most about for this tutorial, which is Facebook's Prophet model. We just import the Prophet model object from fbprophet. If you want to run this locally, then you'll first have to pip install Facebook Prophet before you can import this. We're also going to pull in some error metrics that we can use to evaluate our model. And I've actually defined a function down here for a different type of error metric called mean absolute percent error. The nice thing about this metric is it gives more of an easy to understand metric that we can use to evaluate, because we're looking at the average percent off that our prediction is from the ground truth. As I said before, we have hourly power consumption from PJM. This energy consumption has some unique characteristics, and we're just going to read it in using Pandas read CSV. We're going to give it the index column as 0, and we're also going to have it parse the date column of 0. And if I run this, you can see that we now have an index of our date time column, and we have this PJM East megawatts, which is the value we're going to be trying to predict. Let's also plot this just so we can see what it looks like. So I'm going to make a color palette first. Just pull this from Seaborn. And then I'm going to take this data frame and I'm going to plot with the fig size. Let's make these markers smaller so it's easier to see, and go ahead and plot that. So here we can see this data is going from 2002 all the way to 2018. And you can see already that it has some trends in the data. And as we dig down deeper, we're going to see it even has it at the hourly level, some trends that we can pick up on. So in order to visualize those before we get into modeling, let's make some time series features. Now these time series features we don't actually need for the Prophet model, but we're going to use them just to visualize what the data looks like. So I've already written this create features function. Because it's not needed for the model, I'm not going to go into too much detail about it. But what it really does is it takes this data frame that has an index of a time series, and it pulls out different features about the date time index. So the date, the hour, the day of the week all become their own variables or features about that row. I've also added some things here like cutting into spring, summer, fall, and winter. Let's go ahead and run this. And we're going to concatenate the output as features and target. And that basically is the same data that we had before, but instead of just the index of a date time and PJM East megawatts as our only output feature, we also have all these other features about this date time, including the weekday and the season here. So now that we have that, let's go ahead and plot some of this data. So I'm gonna actually make a subplot with matplotlib. And using a box plot will be a good way to visualize how some of these features relate to each other. So let's make this data equal features and target. Our X value is going to be weekday, and our Y value is going to be this PJM East megawatts. We'll color it by the season value that we made and make sure I'm adding it to that. And also I'm going to make the line width 1 so it's easier to read. And let's add some other features to this plot before we plot it. There we go. So this is a nice plot to see that our day of the week feature does seem to play importance into our predictions, but also the season is very important. So we have peaks in the winter and summer, and the lower seasons like fall and spring tend to have less power consumption. Okay, but we want to do some forecasting. So in a previous video, I talked about very detailed way that we can do cross-validation for time series. But here, just because we're trying to explore this model, I'm just going to do a train test split of our data so that we can train a profit model and see what the predictions look like. So what I'm doing here is I'm going to split our PJM East data by January 2015, which cuts off those last 3 years that we'll use as our test data. And then I'm also going to plot it so we can see exactly what the train and test look like. Let's also make this marker style smaller. Now we can see how we've split our data that we'll be using to train our model on. So everything here in red will be our training set, and then our test set we'll use to evaluate our model, it will be in blue. All right, the next thing we want to do is actually train our profit model. But profit does expect the data to be in a certain format. So the main thing is that it expects a column with the date time type, which currently in our data frame is the index, and it needs it to be named DS. And then our target variable, which currently is that megawatt value, it requires it to be the value Y. So that's pretty easy for us. We can just take this PJM East training data and use Panda's rename to rename the columns into what we would like it to be. Now, if I show you PJM East train profit, this has DS and Y as our column names. And once we have our data in that format, it's pretty easy to actually train the model. So remember we imported the profit model before like this. We're just going to create a profit object. Now I'm going to show you some of the parameters that you could use within this when you're training your own model. We're going to keep most of this as the default just to see how it predicts, but you can add change points. You can change the growth type. You can do a lot of things just using your knowledge and imparting that into your modeling to account for your data. So we're going to make this our model, and then we're going to take our model and we're going to run fit on this PJM East train profit data frame, which we know is in the right format. I'm also going to add the time command at the top of this, which will show you how long it takes for this to run. And we'll cut that part out so you don't have to sit here and watch the model train. All right, our model is done training, and you can see it took about 4 minutes here to train on about 10 years of data. So now that we have a trained model, we can actually just run predict on it. So we could take our model and run predict and predict on a new data frame. Now we do have to create that test data frame in the same format with the correct column names. So I'm going to go ahead and do that by doing this rename, and then we will, or this needs to be PH, and we'll save the result as a new data frame called PJM East Test Forecast. Okay, so that's done running. And now we could take a look by running a head command on the data frame that our model predicted. Now you'll see here that this data frame has more than just the output prediction. Remember, this is an additive model, so it's actually showing us each of the components of the prediction in our output here. So we have the trend, additive terms, yearly trends, and then all the way here to the right, we have Y hat, which is the predicted value for this test set. Now that's a lot of features to get a handle of. The nice thing is that Profit's model actually comes in with some built-in plotting functions that we can use to visualize this. So let's make another subplot, and we'll just take our model and run the plot. We'll plot on the forecast value, which is this data frame. And we added a title to it. So now we can see this is our forecasted value going into the future. The dark values are the actual forecasted value, but then we also have some confidence intervals. And this will tell you the upper and lower bounds of what the model thinks is reasonable for a prediction into the future. And you can see that always the confidence interval is going to become wider as you try to predict way further out into the future. So the nice thing about having confidence intervals is you can say to yourself, not only do I think this is the predicted value in the future, but this is the predicted range in which values are expected to maybe end up. But there's more than just visualizing the predictions that we can do with this model. We can actually take the model and we can plot the components of it. So if we run this on the forecast, so when we're plotting this, we're also going to have it show the uncertainty values. But you can see that's broken it down here into just the trend value over time, which for this data, it sees as being mostly flat. Then yearly, which has some ups and downs that we saw when we plotted using the exploratory data analysis, that we have these two peaks in the winter and in the summer. Then when it's broken it down into the day of the week, so weekends having slightly lower values than weekdays. And then finally, within the day, this is the hourly component of the trend that the model picks up on. So now you can see how these components combined together actually combine to create our forecast. And that's a great thing about Prophet that makes it easy to understand and easy to explain. Okay, but let's run some evaluation metrics to see how well this model actually did in predicting. And we'll compare the forecast to actuals by plotting the actual values alongside our model predicted values. So let's go ahead and plot that. And we'll see here now in red, we have the actual values, and in blue, we have the forecasted values. You can see here that the model may have been picking up on a downward trend in the historic data over time, and it's applied that into the future. It may have been overfitting to that component because as we get further out, the predictions are still within the confidence interval, but they look like they've gone a little bit lower in value than what we would hope to see. And next, I'm going to do the same plot, just zoomed in here at the first month because it's a little hard to see down to the daily value what our predictions look like. So I'm going to take January to February 2015, which is the first month that we were predicting, and we're going to look at the details of the predictions. So you can see here with the red dots being the truth and the blue dots being our forecast. The forecast does seem to overlap most of the times with the ground truth values. There are some exceptions to that, but early in our predicted values, they seem to be on trend with what the actual values look like. And we can get more down into detail by even looking at the first week. So I just have from January 1st to January 8th, the predicted versus actual. And you can see here that the components of within the day are even being picked up by this model, and it's fairly closely following the trend line of the actual values. But of course, we want to evaluate this model with error metrics. And I did import 3 different metric types that we're going to use. Mean squared error, and we'll actually take the square root of the mean squared error, mean absolute error, and then that mean average percent error, which will give us a percent value that's easier to understand when evaluating the model. So first, I'm going to take this mean squared error value. We're going to take it and give it our true value, which is the ground truth, and then predicted value, which is our y hat value, the forecasted value. And we'll take the square root of this to give us the root mean squared error, which is a very common error metric to use. And our error metric is 6,600. This is actually worse performing than the XGBoost model that I've showed in my other video. And then just for consistency with that video, I'll do mean absolute error, which is about 5,000. And then our mean absolute percent error, which is the percent value that it is off on average. And you can see it's about 16.5% off from the actual value when it predicts, which isn't that bad if you consider that it's forecasting way out years into the future. There's still one thing I haven't covered yet about the Prophet model that can be really powerful, and that's that it has built-in ability to account for holidays. And with things like power consumption or sales, anything you might want to forecast, holidays can have a big effect on the forecast. So we're going to show how that could be used if you wanted to improve a model like this. So I'm just going to add a section here called adding holidays. So I'm just going to be lazy here and pull out all the US federal holidays from a calendar built into Pandas, and then we'll load that in as all the holidays in our model. So the way we do that is from the Pandas T series holiday library, we're going to import the US federal holiday calendar. We're going to create our calendar, and then we'll actually make a data frame from the start to the end days of our PJM East time. So you can see these are all the holidays. I'm actually going to identify each holiday as being unique. So if we go to holiday names here and do a value counts, we could see most holidays appear 17 times or 16 times in this data set. And these are all the main holidays on the US federal calendar. Now I'm going to create another Prophet model, but this time we're actually going to provide it holidays. Oh, and we have to do some renaming here. That's right. So it's expecting the data to be in the format of, we can reset this index, rename the columns index as DS. I believe this is the way that the model expects it to be provided. There we go. So we just need to make sure that we have, for the holidays we provided, a DS column with the date and then the holiday name in a holiday column. So that was pretty easy. And then we'll call this model with holiday. And we'll go ahead here again and retrain this model on our training data. And while that's training here, I'm just going to save our prediction, which will essentially be the same thing we did before. We'll predict on the test set. And then we'll also get ready here to plot the different components here. And once it's done training, we'll see that those components will also include a holiday feature to them. So the model is done training. It was a little quicker that time. It took about 3 minutes. And we will now run this predict and create our forecast with holidays. Now that the prediction is done, let's take this output data frame and run a head command on it again. And we could see that each holiday now actually is its own component. So it's broken down and it'll have different effects on the model. So if I want to plot those components, we could see our components look very similar to the previous model that we trained, but now we have this holiday effect. So you could see certain holidays actually pull down the prediction of the model, and there are some that actually make the forecast go up. Just to visualize this, let's go ahead and take one of these earlier plots that we made with our predictions versus the truth. We'll predict out our forecast with holidays. Let's do the week of July 4th because we know that's a holiday, and plot this out. So we can see here the July 4th predictions are a little bit lower, and the actuals were definitely lower on this day due to the holiday. And finally, let's do the same evaluation metrics that we used before to compare how the model's results are. So running these on our holiday predictions, we actually see that the model performs slightly worse with these. And it could be for a number of reasons, but the holiday effects really didn't impact the worst of these models. Now, if we just checked on those holiday dates, we may see an improvement of the predictions only on those dates, but overall, really didn't impact the model too much to add the holidays. Now, finally, what we're going to do is just predict into the future. And the nice thing about Prophet is it actually has this part built in. So we can take our model object and run this make future data frame and provide it the number of periods. So let's say periods equals 365. It's actually going to make 365 hourly components. So let's multiply this by 24. So this is including the history, but we can turn history off. And we'll also add in the frequency equals hourly for hourly data frame. Now, if we had trained a model on data all the way up until today, then we could make this future data frame going forward into the future. But for this example, we're just pretending like we have the data up until 2015. So we'll call that our future. So let's go ahead and run this model with holidays, prediction on the future, and we'll call this our forecast. And then we'll run a head command on that. And you can see this forecast has what would be future dates and has all of our components. And if we just subset down to y hat, we can see the actual predictions for those future dates. Thanks for watching the video. Make sure to subscribe and I'll see you next time.